Hello again. In our previous session, we started discussing probability, and I indicated that it was the foundation for statistical inference. With the background in probability, we will now introduce probability distributions in session 5. Now, each outcome of an experiment has an associated probability, as we saw previously. And the probability of a probability distribution of a random variable basically lists the possible values of the random variable and their corresponding probabilities. So this is what we'll be looking at, and then we'll generate the probability distributions and calculate various probabilities. And when just as we saw in frequency distribution, we'll be able to calculate the mean, the variance, and the standard deviation. At the end of this session, the student will be able to define the terms probability distribution and random variable, distinguish between discrete and continuous probability distributions, and then also calculate the mean, variance, and standard deviation of a discrete probability distribution. So this is how the outline is organized. We begin with random variables. What is a random variable? Now, you know that most statistics, just like the sample mean, are random variables. Because you see, depending on who is included in the sample, let's say if we took a sample of this class, econ 214, and we wanted to compute the average age of the students, then depending on who we are taking, the value of the sample mean will vary from sample to sample, because you know, when we ended up taking older students in a class, the mean will be high. But if we ended up taking younger students in a class, the mean will be what? Lower. So it means that the value of the mean would occur by chance. So anything that happens by chance, or any numeric event which happens by chance, is called a random variable. So a random variable is said to be a numeric event whose value is determined by a chance process or an experiment. So let's take this example. Suppose we roll 2 dice and take the sum of the numbers showing up. Now, this sum is clearly a random variable because its value is determined by chance, right? And such an experiment produces 11 possible values. And these numbers are 2, 3, 4, 5, 6, up to 12. Why? Because you see, the minimum should be 2, because when you roll 2 dice and 1 shows, when you sum them, the value will be 2. But when 6 and 6 show and you sum them, it is 12. But in between, you can have a number like 7, because maybe either 1 and 6 show, 2 and 5 show up, 3 and 4 show up, 4 and 3 show up, 5 and 2 show, or 6 and 1 show. So you can get these range of values. So we're saying that these are the possible values that we can obtain when we roll 2 dice. And each of these values has a probability associated with it. But these values we're saying that they are random variables because they occur by chance. The sum 12 appearing occurs by chance if 6 and 6 show up. This is another example. We toss a coin 3 times and observe the number of heads that show up. Now, we can generate the sample space this way, because when you toss a coin 3 times, it is possible that no head will show. In that case, you have tail, tail, and tail. But there are other possibilities, and the other extreme is that there are 3 heads, head, head, and head. So it means that if our random variable, we have defined it as the number of heads showing when we toss a coin 3 times, then the random variable x, which is the number of heads, we'll take four possible values: 0, 1, 2, or 3. So that's it. And many random variables have well-known probability distributions associated with them. And that's what we are about discussing. So let's look at discrete and continuous probability, random variables, sorry. A discrete random variable is a variable that can assume only certain clearly separated values. We saw that earlier, and I said they are either countably finite or countably infinite. For example, let x be the number of heads when a coin is tossed 3 times. So the value of the random variable, the number of heads, is 0, 1, 2, 3. Okay, they are clearly separated, distinct values. A continuous variable, on the other hand, can assume any one value within a given range, or they can assume an infinitely large number of values. Okay, so let's say height of students in this class. Now, some standard probability distributions are what we call the binomial distribution, and it is a discrete distribution. The Poisson distribution, it's also a discrete distribution, and then the normal distribution. These are very important distributions that we'll be discussing. Now, binomial distributions or variable, how do they arise? Now, when the experiment that we are conducting has only 2 outcomes, in other words, you toss a coin, it's either a head or a tail, right? Or you write an exam, you either pass or you fail. So, or a firm produces a product, it's either good or bad, or better still, you say it is defective or non-defective. So there are only 2 possible outcomes. But for Poisson, they are said to be very rare events where the probability of occurrence is very low. For example, the number of accidents happening on the Temamoto Way every day or in a day. Okay, these are rare events. We don't expect accidents to happen very often, okay, on the road. So maybe some days you don't get it at all, and some days it's only 1, maybe 2, but it doesn't happen. Meanwhile, you know the number of cars, thousands of cars ply that road, but the event is very rare. So that's for Poisson. And then normal, when there are so many independent factors influencing the variable. For example, a person's IQ is influenced by the person's genes, your diet, and a lot of factors. So these are the examples. Now, let's zero in on discrete random variables. So we'll look at the probability distribution for a discrete random variable. Now, each random variable, as we said, has an associated probability. And the probability distribution of a random variable basically lists all the possible values of the random variable and their corresponding probabilities. So if probability Px, or probability of x, is the probability associated to the probability that x is the value of the random variable, then we can write this formula. When we sum over all probabilities, it should be equal to 1, as we saw earlier. So let's take this experiment. Suppose we toss a coin 3 times and want to observe the number of heads. The possible values are 0, 1, 2, and 3. So what is the probability distribution of the number of heads? We can put this in a table, because if we define x, a random variable, as the number of heads, then when you toss a coin 3 times, you either get 0 heads, 1 head, 2 heads, or 3 heads. But we can also put a column to see the number of ways you can have each of these number of heads appearing. Okay, so we say the frequency. Now we have only one way in which 0 heads can appear. That is when in each of the tosses only tails appear, right? But there are 3 ways in which you can have one head. That is, implicitly, we are applying a combination formula, right? Because when you toss a coin 3 times, there are 3 ways in which you can have one head. Maybe you have the head on the first toss, then tail on the second and the third. In other, whether it happens that way, you have one head. Or you can have tail first, head, and then tail. It's 3 tosses, but there's only one head. So that's the second way. Then you can have tail, and then head. That's the third way. So the number of heads of 1 can appear 3 times. Then you can also have 2 heads. The number of times it appears is 3 times. And then 3 heads also occurs once. So that is when you have head, head, head. So you can calculate the probability, as we saw earlier, is that the number of times the event happens times the number of times outcomes. So it is the total frequency gives you the number of outcomes, which is 8. So the probability of 0 heads is 1/8, or 0.125. The probability of 1 head is 3/8. Happens 3 out of the 8 outcomes, right? So it's 0.375. It's also 3/8 for 2 heads, and then 1/8 for 3 heads. And again, when you sum over all the probabilities, you get 1, right? Using a summation sign. And this is an example of a probability distribution for a discrete random variable, where it lists the possible values of the random variable with their associated probabilities. Now, just as with frequency distribution, we can find the mean and the variance of the random variable. Now, for a random variable, the mean has another name called its expected value. So normally we call it the expected value, or the mean of the random variable, and written as mu of x, or you can write it as E of x. So E means expected value of x, and it's equal to summation of the product of the value of the random variable by its associated probability. In other words, multiply the value of the random variable by its associated probability and then sum it. When you do that, it gives you the mean, or the expected value. So let's illustrate. Let's say we toss a coin 3 times, and we want the number of heads as the random variable, and we want the expected value of the number of heads, or the mean number of heads. Since we know the heads, or the x's, take on the values 0, 1, 2, and 3, we multiply each of them by their associated probabilities, as we saw in the previous table. So 0 times 0.125, 1 times 0.375, 2 times 0.375, and then 3 times 0.125. And then we sum them. When we sum it, we get 1.5. So this is the expected value, or the number of heads we get. It doesn't mean that when you toss a coin once, you get 1.5 heads. It means that when you toss a coin a number of times, sometimes you get 0 heads, sometimes just 1 head, other times 2 heads, or other times 3 heads. On average, when you do that a large number of times, the average number of heads you get will be 1.5. And then we can find the variance of the random variable, let's say the number of heads. So it is computed using this formula, sigma squared, which is the variance, as we saw, and it is given by this formula. So again, you have the deviation from the mean squared multiplied by the probability of the value of the random variable, and then you sum that. Now, this formula can also be simplified in this form. And as usual, to obtain the standard deviation, we just take the square root of the variance. So this is illustrated in this table. So we know the random variable, which is the number of heads, takes the values 1, 2, 3, 1, 2, and 3. The probability associated with each of them is this. So when we multiply the value of the random variable by its associated probability, this is what we get. When we sum, we get this as the mean, right? Now to find the variance, we said there are two ways. First, you can do x minus the expected value and then square it and then sum it, right? Sorry, you square it and then multiply that by probability of x and then sum it. It gives you 0.7502, right? So this is the variance, because this is what we've actually done in the form, this first formula, right? When you compute it, then you sum. So we got them and summed them. This is the variance. Alternatively, you can use this formula, which is summation x squared px minus summation x px all squared. And note that summation x px is simply the expected value. So it is minus the expected value squared, right, which we got as 1.5. So when you come here, we can find x squared, and then we find s squared times px, and sum it. It gives us 3. So it gives, that is this part of the formula. And then we know that once we have summation x squared px, we subtract from it summation x px squared. So it is the 3 minus the expected value squared, which is 0.75, which is the same as what? 0.75 here, right? So either way, you get the answer, the same answer. And then when you take the standard deviation, it is equal to the square root of 0.75, and it is 0.87. So let's illustrate with an example, okay, just to facilitate how you solve the problems. Now let's say the managing director of Perfect Painters, a painting firm in Accra, has studied his records for the past 20 weeks and reports the following number of houses painted per week. Compute the mean and variance of the number of houses painted per week. So this is the data. Number of houses painted 10. The weeks in which they were painted 5 weeks, 6, 7, and 2. So 13 painted in 2 weeks. So you have this table. So all we can do is for each of them find their associated probability, because you know the number of weeks here. When you sum the number of weeks, this is 11 plus 9, 20. So this first one, which is 5 weeks, this column is 5 weeks. It should be 5 divided by 20, right? So 5 divided by 20 is 0.25. You do it similarly for all of them, you get these values. So you get the probabilities, and the sum should be 1. So you can compute the mean. The mean number of houses painted per week is 11.3 with a variance of 0.97. Of course, you can calculate the standard deviation by taking the square root. So it's just a matter of applying the formulas. This brings us to the end of probability distributions, and then where we looked at both types, continuous and discrete, but then we focused generally on the discrete distribution. In our next session, we will take the 2 special cases of discrete probability distributions, that is the binomial distribution and the Poisson distribution. See you soon.